7th grade, Chapter 8, Section 6, Classifying Triangles. Our objective today is to classify triangles by their side lengths and their angle measures. So here's some vocabulary for us. Scalene triangle. A triangle with no congruent sides. Every side is a different measure. So this is one measure, this is a second measure, and this is a third measure. No congruent sides. The next triangle is isosceles triangle. It has at least two congruent sides. So when I think of the isosceles, I think of our tall, skinny ones, where this side is one measure and these two sides are equal. We then have the equilateral triangle. That's our easiest one. We have three congruent sides, and so it's one of those perfect triangles. Equal, equal, and equal. So these are all how to do triangles by the sides. The second way to classify triangles is by their angles. An acute triangle has a triangle with all angles measuring less than 90. So, if I have a triangle whose angles are less than 90, I have an acute. This is less than a right angle, this is less than a right angle, and this is less than a right angle. Now, an obtuse triangle is a triangle containing one obtuse angle. You can really only get one obtuse angle in a triangle. Here's our big obtuse angle. These guys are still acute, but if I have one obtuse, that classifies it as an obtuse triangle. And our easy one is the right triangle. Well, I better have a right angle if it's going to be classified as a right triangle. And, whoops, I drew the same one again. That right angle can be anywhere on your triangle as long as you do have that perfect 90 degrees. And these are the ways to classify a triangle by the angles. So every triangle has two names. A name according to its angles and a name according to its sides. So let's look at our first triangle here. They've given us some measures to help us out. We have a 5-foot side, a 9-foot side, and another 9-foot side. So I have two congruent sides, so that has to be isosceles. That's a hard word to spell. Isosceles. And looking at my angles, well, that's less than 90. That's less than 90. And that one is definitely less than 90. So if I have three acute angles, it is an acute triangle. So the two names for this triangle are isosceles and acute. So I've made a lovely chart for you here so that you can see all the different ways they match up. Here are our sides: equilateral, all equal sides; isosceles, two equal sides; and scalene, none of them are the same length. And then our triangles by angle: acute, less than 90, right, measuring exactly 90, and obtuse, more than 90. So let's look at some triangles down here and see if we can classify them. So we're going to be talking about the sides and the angles. Let me get all this on here. So here's our shape over here, our polygon. All of them are line segments, and it is a closed figure, so our definition polygon fits this. We want to know how many right triangles you see in this shape. Well, we can always tell it's a right angle by that lovely square they make for us. So, here is a right angle, and here is a right angle. So, to name our triangles, we pick its vertices wherever they have letters. How many did we see? Well, I saw two. I saw triangle B, D, C. So triangle B, D, C. And I also saw triangle B, A, D. Triangle B, A, D. Let's look for an isosceles triangle. Now, isosceles triangle has two congruent sides. So, do we see a triangle that has two sides that are equal? Well, I see slash marks here, and I see slash marks here. So, these two sides are equal. So, if I look at my triangle like this, there is an isosceles triangle. And now I'm going to see only one that they've marked for us. There might be another one there, but let's just look at the first one here. So I'm going to say I see two. I see triangle BAC, and I do believe that this is also an isosceles triangle. They didn't mark these, but it's in the center. I'm going to say that that too is an isosceles. I believe that CE and AE are the same length. So also triangle AEC is isosceles. So let's look at our acute triangles. I'm going to get rid of this stuff here. And look for something that's acute, which means it has to have less than 90 degrees. Okay, so where's some less than 90? Well, that's less than 90. 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 So where do I see one that's less than 90? Is all this less than 90? I think it is. So I also have BAC again as an acute triangle. I don't see anybody else. If I do this one, it's right again, isn't it? This one, I don't know if that's right or not, but I don't think it's acute, so I'm going to say I only see one of those. So let's try our next kind of triangle. Now we're looking for scalene. No sides are the same. Let's see. If I'm just looking at sides, this side, and this side, do those have the same length? Any of them? I'm going to say no, they're not. So I'm going to say that triangle ABD is definitely scalene. Well, if this one's scalene, I'll bet this one's scalene too, because to me they're the same triangle, just reflected. So I'm going to also say that triangle BDC is scalene. So we saw two. All right, last kind of triangle, obtuse. Remember, obtuse has to have an angle greater than 90 in it to be obtuse. So, where do we see that angle that we didn't think was right, but we knew it was bigger? I think that was angle E. So if I were to name this triangle, I would say that triangle AEC was obtuse, and we only found one of those. That's how you classify triangles, by sides and angles. That's the end of Classifying Triangles, Section 8-6.